Okay, so we're going to be talking about finding the area of a regular polygon. So, um, quite a second. There are two different formulas you could use. To me, one is more intuitive than the other. Well, actually, they're both intuitive. Let me take that back. But when you don't know and this is for just in the case when you don't know your apothem, which is the height of your triangle, or your side length, your base. So it's 1/2, it's going to be the number of triangles the number of sides you have, or the number of triangle partitions you have, times 1/2 your side length times your apothem. Another formula you could do to check yourself, I guess, sometimes is if you just know what we call this diagonal one, the circumradius. If you only know the circumradius, you can also plug into this formula 1/2 times your circumradius times your radius, right, squared, times n being the number of sides times sine of 360 over n. So let's just navigate this. It's very important that you know exactly what you're talking. Well, it's not very important, but it's good if you know what you're talking about. So for me, it's to just know you're trying to divide this polygon into triangles and then find the area of one of the triangles and then multiply it by how many triangle partitions you have. So I will do this example first. So here we have I'm not sure how many sides. I think it's 1, 2, 3, 4, 5, 6, 7, 8. 8. We have an octagon over here. So we're going to partition this octagon into how many triangles it has, and then just hone down on one of the triangles. All right, so let's get to it. All right, so this octagon should have 8 triangle partitions here. N is always equal to the number of sides, or the number of triangle partitions you have is always equal to the number of sides you have. So I'll show you that. So you just go from your center. So I think step 1 is to, oh Jesus, give me 1 second. I don't know why it's doing this. Step 1 is to just draw your partition your polygon into different triangles. So this polygon you go from the center to each of your vertex, right? So it has 1. That is so terrible. I'm just going to go from the vertex to the center. This is terrible, but I hope you can see it. I'm just going from the vertex to your center, right? To see how many triangles I can make here, which should be 8, because that's how many sides I have. I'm sorry, my line is a little wonky. This is terrible. All right, so I have 1. So if you would see here, I have 1, 2, 3, 4, 5, 6, 7, 8 equal triangles I can make this polygon to be. I'm sorry if my line is a little wonky, but we're just going to focus on finding the area of one of these triangles. So we'll just focus on finding the area of here, and then multiply it by 8 to find the area of my complete polygon. So that's just all this first thingy is saying, this first formula is saying. So step 1 for this is to partition your polygon and find the number of triangles you have, which is the number of sides. Or you could just say step 1 is find how many sides you have. I cannot see my mouse. What is going on? Step 1, find n. And here we have 8 triangles we got to think of. In this case, n equals 8. Now, step 2 is to find the central angle of your polygon. Now, the central angle will be just 360 divided by how many triangles you have with partitions. So 360 divided by n. So step 2, find your central angle, and that'll help you find your base and height of your one triangle. Step 2, find central angle. So it's taking so long to type in here. All right, so my central angle right here for this one is going to be, I'm gonna just make it, let's say pink. Let's just make so you can see it. Or fuchsia. Okay. All right, so my central angle is just the angle of this triangle right here. So the entire thing is going 360, right? So we just do 360 divided by 8 to find just that angle right there. So my central angle, you would say, you always say 360 divided by n. Okay, so 360 divided by 8, I will ask Google real quick. Hey, Google, what's 360 divided by 8?
360 divided by 8 is 45.
Okay, 45. So my central angle for this polygon is 45 degrees. So now I'm just going to look at one of this triangle and find the area for one of these triangles and then multiply it by 8 because I have 8 triangles, okay? So find out, I have 8 triangle partitions, find out my central angle. Now let's just take one triangle, right? And we're just going to draw it. So step 3, this is going to have a lot of steps, by the way. It's just to take out that triangle and draw it so you can look at it. Draw that one triangle partition. So here we have, this is one of my triangles. And I know, okay, the central angle here is 45 degrees. So this is a 45-degree angle right here. This is going to be important. And then I know that one of my sides is 6.6 yards. Now, how do you find the area of a triangle? If you said have base times height, good. Good job. So with this triangle, what is my base and what is my height? We don't know, right? Exactly, good. Which is why this angle, this 45 degrees will become very important. All right, so let's go ahead and find out. So now we're going to try to find out what is my. So what we're going to do is we're going to draw a perpendicular line right from the apex of my triangle to the middle of the base. And that creates two right triangles, right? When we cut this triangle in half. So what we're going to do is just look at half of this triangle to help us find out. So look at just one of these two right triangles I have, just half of this triangle, to help us find out our base and our height of this triangle. And your base is just your side length, right? It's just the side length over here, but we don't know the side lengths. So it would be just the side length if we knew the side length, but we don't. Do a different color real quick so you can know what I'm talking about. So your base will usually just be the length here, side length, but we don't know it. So we're gonna use our trig ratios to find out our base and height. All right, so step 4, sorry, is to now draw your half of your triangle partition, which is what we're going to do here to help us find our base and height. I told you it's going to be lots of steps. All right, so here we're just going to look at this triangle and we're drawing half of it to find our height and our base. Now, when you would cut the triangle in half, you have to remember that this angle up here will be half of your central angle. So we're going to find out what half of 45 degrees is. Hey, Google, what's half of 45?
The answer is 22.5.
Okay, so this angle of just this half triangle will be 22.5. And that will become very important. All right. So now we'll use that 22.5 to help us find our base and our height. We do know our side length is 6.6. That's also important to note. Oh, let me use it right here. Not side length, I'm sorry. Our circumradius is 6.6. So I'm gonna write that right here, 6.6 yards. All right, so I'm gonna put, once you draw that half of the triangle, you want to go ahead and put H for height or A for your apothem. I just put H for height because I just don't have base and height. And then half of your side length is your base. So I'm just gonna put over here, I'm gonna put my base, which is half of, I'm gonna put B over 2. I'm gonna have to remember that that's always gonna be half of my base when I've halved the triangle, okay? All right, so now we're gonna go ahead and find height and our base with what we know. All right, so first I will go ahead and solve for height. So in relation to my angle, I see my angle is 22.5 and I see that the height is adjacent to that 22.5. And one thing I know for sure is the 6.6 yards, my circumradius. So if we're looking at this, I know my adjacent and I know for sure my hypotenuse. But what I don't know is my adjacent and my opposite. So let's just find for the adjacent. So what you want to do is now go ahead and say, okay, H is adjacent and I know hypotenuse. So what trig ratio relates adjacent to hypotenuse? If you said cosine, good. So I'll go ahead and say, so let's solve for H first. We'll say, okay, cosine of 22.5 is going to be equal to my height over 6.6. H over 6.6. So I'll go ahead and write H over 6.6. And then 6.6 yards on YD. So to solve for H, I'll just multiply 6.6 on both sides. And I get that 6.6 cosine 22.5 equals my height. Okay, next I have to find the base of my triangle. So remember I have my triangle, so we're just looking at half the base in this particular triangle. So the base is opposite from your angle, and or half the base is opposite from your angle. And remember, what do we know? We know base. What do we know for sure? We know the hypotenuse. So what relates opposite and hypotenuse? If you said sine, good job. So then you're going to say, okay, first set up the ratios. So you're going to say sine of your angle equals the opposite over hypotenuse. And you're going to put in your angle. So I'm going to go ahead and say sine of 22.5 equals not really my base, but half of my base, half of my sideline. Sorry, excuse me. Sorry. So I'm just gonna say base over 2 with over 6.6. I'll say base over 2 just so I remember that is half of it. .6 yards. So then I'll just multiply both sides by 6.6. So 6.6 sine 22.5 will give me half my base. All right. So now let's go ahead to just plug these into calculator, find the base and half my height of my triangle. So I'm gonna go ahead and plug that in the calculator. Let me stop sharing for a minute. I share my whole screen so you can see the calculator and the problem. All right. So I'll go here. I'm gonna find out what cosine of 22.5 is. Which is 0.9238, and then I have to multiply that by 6.6. So that's about 6.0, 6.10, 6.10. I'm going to do it to do decimal places. So that's about 6.10 yards. And I say yards because we multiply by 6.6 yards. So the height of this triangle is about 6.10 yards. I'm going to go ahead and write that there. So once I find that, I'm going to go, okay, this is 6.10 yards. And then the base is 6.6 times sine of 22.5. So we'll go ahead and do 22.5 in our calculator, find out what sine of that is. It's 0.382. So I'll multiply that times 6.6 in a calculator. That does not look right. Hold on, give me 1 second. 6.22.5 sine of it times 6.6. So that's about 2.52. I was like, that doesn't look right because it looks too small, but I forgot that is half of my base, half of my side length. So my entire base will be something like 5, which is good. That's close to 6, so that makes more sense. Okay, so I get half of my base is 2.53. So I'm gonna just write that here. And so now 2.53. What I can go ahead and do is just multiply, because the area of a triangle is half base times height. But remember, we already just got half the base. So we literally can just do half base times height. We can do this 2.53 times 6.10. And that'll get us the area of the entire of that one partition, triangular partition. So that's probably what I'll go ahead and do, rather than setting up the entire thing and saying half times side length times. Nah, I can just go ahead and say, okay, I know 2.53 times 6.10 is already half base times height. So I'm just gonna say this. Let me do times 6 cosine 22.5 just to get it more exact. I'm gonna do parentheses 6.6. Now I'm going to 22.5 cosine of 22.5. Just to get it know exact. But just looking at it, it's like 6.1 times 2.5. So it should be around 12 point something. A little bit greater than 12. So always look at it and make sure your answer makes sense. You'll find an answer that makes sense, right? Okay, so I get like 15.4, which is good. I just knew it had to be close to a little greater than 12. This makes sense. All right, so I get that the area of this triangle partition is 15.4. But remember, we have how many triangle partitions? We have 8. So I'll go ahead and see it here. So I'll just write it right here. So area of this one triangle is 15.4. And then I'll just go ahead and multiply 15.4 times 8. And that'll give me the area of everything. So times 8 is going to be 123.2. So the complete area of everything is 123.2 yards squared. Ooh, that was terrible writing. If you didn't quite get it, so once you get that half base, you can actually go ahead and double that base, but you can just say that half base times your height. And then times the number of triangles you have. So we can just say n times we already know b over 2 half base times height. Times our apothem, which is our height. And which is what I did there. See, 1/2 base times height times n. And that just is the same thing as this. So once you know half of your base, multiply that by your find out your height first. That's to me, that's the most straightforward. And that'll be like cosine of your angle times yeah, times your hypotenuse. And then find out your half of your base, what half of your base is, multiply those two, and then that'll give you the area of one of your triangles, then multiply by how many triangular partitions you have, or the number of sides. So that's how you do with that. You can also double check with the order formula, which is half times your radius squared times n times sine of 360 over n. So let's just double check it with the other thing. So our second radius is 6.6, and this is an octagon, so n is 8. So we can say 6.6 squared is 43.56. Multiply that by a number size, which is 8. Multiply that by a half, because half time, I'll just do 0.5. And it's because half radius squared times the number size. Then multiply that by sine of your central angle. Our central angle was 45. So we just type in 45 here. And sine of our central angle is 0.7. And we can see we get the same thing, 123.2. 123.2 yards. So you can use either formula. You can either find the area of one triangular partition and then multiply that by how many triangle partitions. So you could plug it into this half times the second radius squared times your number of sides times sine of your central angle. And it should also still give you the same answer. All right.